So we're going to plot the points, obviously, but you're not going to connect them. Don't connect, where's my pen? Don't connect the plots. So we'll put steps here. You'll put boxes here. And so, let me see, what do I have? 1, 2, 3, 4, 16, 64, 256. Yeah, okay, so that's good enough. So this is ideally what you guys want. So if we ask you to graph, fill out the table, and give us recursive explicit, this is expected of you, okay? The top is just warm up, okay? All right, so step 1, we have 4. It's going to be really small. Let me just do it in orange so you guys could see it. 2 is 16. Oh, that was, oh, you guys, I missed it. You guys see that? This was 0, this is 1. It looks like a 2. I know, you guys, like, what the heck? I thought that was a 2 really quick. This is the 2. So that's the one that's a 0, like, duh. All right, so my points are a little off. So, yeah. Okay, so that should be here. That should be here. The printer. It wasn't pretty. Okay, 3 is 64. And then 4 is 256. Yeah. Okay, we wouldn't connect the dots, but an exponential growth function, so if you have an exponential growth function or equation, they usually, oops, the graphs typically look like this. You guys, have seen them in like im2 or middle school? Yeah, a little bit. I don't know if you've really worked with them. Okay, an exponential decay function. This is very medical. Like if you ever got what's the poisoning where it's like if you're in a car or it's dioxide? What is it? Not carb, but is it? No, it's is it start with an M? Yeah, what is it? Yeah, what's that? Is it? Oh my god, you guys, how do I not know? Paulo, what's the poisoning that if, say, you're in a car, or like people have to go to the hospital because...
Oh, yeah, carbon monoxide.
Is it that one? Oh, okay, my bad. All right. Okay, yeah, so if you want to get it out of your system, it's an exponential decay function. So when you watch your body, if they try and get it out of your system, it's an exponential decay function. So, you know, they'll hook you up to oxygen, whatever the doctors do, the nurses do for you. But it's an exponential decay function. And then it's also, your body really doesn't get rid of it. So if this is 0, it kind of just very, very low amounts linger. So if you guys study fungus, bacteria, you guys going into bio, public health, these are your exponential growth. They're not linear. Medical is never linear. Okay, it's usually exponential growth, decay. You know. Okay. You guys see The Last of Us? That show. I think I watched 2 episodes. I'm like, okay, I'm kind of grossed out. Okay, here we go. So you guys would plot the points. If they asked you, so say they give you this, but you don't know the title. They give you this diagram pattern. You plot it, you put in the table. You then see that from term to term, you're multiplying by a times 4. So that's the commonality. As you're going from step to step, your total boxes is what is the difference? It's a multiplication of 4. That is your, bright light blinging. So if I ask you what type of functional growth is this, or pattern, you would say, is it exponential, quadratic, or linear? We haven't taught quadratic yet. Is it linear, exponential? It's exponential because it has a multiplicational growth. So it's exponential. That's it. Okay? You guys are great with it. Okay, so now recursively, you're awesome with this. you just have to give me the initial and the general term. So your initial term is on step 1, what is the data? So in step 1, f of 1 is equal to what? 4. The first drawing has 4 boxes. That's it. You give me the very first. And then after, it's the general term. And that is what we have up here. That as you go from step to step to step, if I want to know what f of n is, I'm going to look at the prior term, and what am I going to do to that prior term? To go to the next term, times 4. And that is your recursive equation. Always 2 terms. Okay, what is explicit? An exponential function, whether it's growth or decay, it is y equal a to the x. This a is your rate of change. Rate of change. So this would be y equal, and what's my rate of change? 4, and then x would be your step. Step 1, step 2, step 3. So if this was times a half, it'd be 1/2 x. Is this what? If this was times -2, it'd be -2x. Whatever that number is, that's your rate of change. This is your a, that commonality. Okay. Okay, and then of course you'll get full credit here, but because these are f of n's, if you guys give me this, then awesome too. Whoops, that's supposed to be an n. So x's or n's, you get the same credit. And if you accidentally did what I just did, where you put the n and you put the x there, I don't dock you. Like, I get it. I do it too. Okay, fair? Yeah, easy. It's easy, you guys. Quadratic, you guys will see. So linear is mandatory. Exponential is mandatory. When we get to quadratic, we'll probably wait a day and then we'll start it Wednesday. The chart is mandatory. The explicit recursive writing is not. That is always extra credit, and that's if you and your partner are up for it. Okay.